Hello again. Looking at a plating problem here, and let's see what they've given us. The 500-gram lead head of a gavel is attached to the negative terminal of a power supply and lowered into a nickel nitrate solution. So we have a big container of nickel nitrate, which would contain nickel 2 ions and nitrate ions, and one assumes water. And into that they put a lump of lead. They connect this to a power supply, and they say the negative terminal of the power supply is connected to the lead. So there we go. The short line is your negative side, the long line is your positive side. So the negative terminal of the power supply pumps electrons into whatever it's touching. So this wire will charge negative. The lead will charge negative. So there's an abundance of electrons in the lead. When these ions see the negative charge, hopefully you know the opposite charges attract thing, the nitrate ions, which are negative, see this negative charge and go ew and move away from it. The nickel ions are attracted to the negative charge and float towards it. And when they touch, the nickel should gain electrons. Anything that touches this chunk of lead is in contact with this huge supply of electrons. So the lead gavel says, here, take some electrons, we have lots. And you can look in the data book for what happens when nickel gains electrons. It's not surprising. Nickel 2 can gain 2 electrons. It goes down to its next state, which is nickel metal. So that's what we expect to see on the surface of the gavel. It'll plate nickel metal onto it. The circuit is completed with an anode made of nickel metal attached to the positive terminal. So this side is less important. We care mostly about what's happening on the gavel, but just for completeness. On the other side here, we have a lump of nickel. The positive side of a power supply sucks in electrons because it attracts them. And so this whole wire will go positive because the electrons have been depleted from it. That goes positive. The nickel will go positive. And if nickel is losing electrons, if they're getting pulled out of it, on this side you would expect to see nickel metal losing electrons. That means it's getting oxidized and turning into ions. So when this whole system is set up, nickel will be dissolving off of this electrode. This will start to dissolve and crumble. Those ions will float towards the left side, and if they reach the lead surface, they should stick there, and we'll get a layer of nickel metal forming. So that's the scene in this plating cell. And their question is, what will be the final mass of the gavel head if a current of 5 amps flows for 10 hours? We have a formula that handles this very nicely that I usually write like this. If you're not used to using this form, the other way that this is sometimes taught is they'll say quit, Q equals IT, and also Q equals FNE, or some variation on that. So you can find the charge first, and then use that charge to find the number of moles of electrons. This is a more compact way of doing it, and it generally works fine. In this question, they say our current is 5 amps. Our time is 10 hours, but I'm not going to put 10 here. Why not? Hopefully you remember this time has to be in seconds. So, okay, I am going to put a 10, but it's 10 hours times 60 minutes per hour times 60 seconds per minute. We're going to get 36,000 seconds for the total time that the current's flowing. So I times T equals, the Faraday constant is 96,500, running out of space, and Ne is the number of moles of electrons. So, math ensues. 5 times 10 times 3,600. We get 180,000 coulombs equals 96,500 times the number of moles of electrons. Divide both sides by 96,500, and we get the number of moles of electrons is 1.8653 moles. If we want to know how much nickel is going to plate onto here, this is not the number, but we're going to need this. The reaction that's happening is we're taking a nickel ion, we're adding 2 electrons to it, and we're getting an atom of nickel. The takeaway from that is for every 2 electrons that you put in, you only get a single nickel atom. The ratio here is 2 to 1. However many electrons you put in, you're getting half that much nickel. So from this number, you could say we're going to get 1 nickel for every 2 electrons, which leads to 0.93264 moles of nickel metal deposited, or plated, or reduced, whatever you want to say. How much nickel is that? Mass equals number of moles times molar mass equals 0.93264 times, what is nickel's molar mass? 58.69 per the data book. $54.7 grams of nickel deposited. All the information we've been given has 3 significant digits, so 54.7 is a reasonable place to stop there. And if they're asking for the final mass of the gavel head, its total mass, it started out with 500 grams of lead, to which we've added 54.7 grams of nickel plating. 554.7 grams should be our final mass. Good?